Hey everybody! Today's lesson will be focusing on factoring algebraic expressions. I've broken this into 5 different parts, so the lesson goal is to factor algebraic expressions using each of the indicated methods. Part 1, greatest common factor. Part 2, grouping. Part 3, sum and difference of 2 cubes. Part 4, the difference of 2 squares. And Part 5, the AC method with grouping. I also mentioned that you should really, at the end of this, be able to do any combination of these methods, whether it's a combination of 2 of them, 3 of them, or all of them. This isn't to say that these are your only methods of factoring that you'll be using. However, these 5 methods are very relevant to algebra, and we will be building from there. But first, you need to know how to add, subtract, multiply, and divide with positive and negative numbers very, very well. I'm not kidding. This is really a serious thing. I'm not going to tell you that you can't use your calculator because you won't always have a calculator on you. That's just not true. Most of the time, we have access to a calculator. But the reality is you need to know how these numbers relate to one another, how they affect one another, how numbers work. If you don't understand that, factoring is going to prove to be very, very difficult. Additionally, I believe it would be quite wise of you to not only write these down, but to practice and memorize all of these solutions. You really should be automatic in your response when somebody asks you, what is 2 to the 5th power? You shouldn't really need to stop and think. It should be as easy as when someone asks you, what's your name or what's your birthday? If you know these math facts automatically, that means it's stored in your long-term memory and not taking up space in your working memory or short-term memory, thus leaving more room for you to work out more difficult problems with your working memory. You really shouldn't be wasting your valuable working memory on calculating these values. Here I'm going to start off with pre-example number 1. Pre-example number 1 goes with the first method of factoring, which will be greatest common factor. What I have us doing here is using the distributive property to multiply 2x cubed and the quantity of 3x minus 5. Factoring by greatest common factor will really be us undoing this process of distribution. The reason I want us to distribute is so we could really analyze exactly what's going on when you distribute, so we can really understand what goes on when we need to undistribute. When we distribute, we're going to multiply 2x to the 3rd power by each term inside of this set of parentheses. Terms are separated by plus or minus signs, not by multiplication or division. That's why 3x is one term in this quantity and 5 is another. 3 and x are not 2 separate terms. Now, let's multiply. If we took care of this 2x by first multiplying it by the 3x, we would see we have 6, the 2 times the 3, x to the, that's the 3rd power. No exponent means 1st power, so 4th power. Now, we're going back to this 2x cubed, and we're going to multiply it right there by the minus 5. Minus, because the positive 2 and the negative 5 multiplies to be a negative. Negative what? Negative 10. X to the 3rd power. Now, before we move on, let's talk about how we can take this answer and go backwards and get back to where we started. Since distribution required multiplication, factoring is going to require division. Some of you can probably undistribute in your head pretty well, and you don't even really think about what it is you're doing. But it is really important that we stop and think about what it is you're doing, because not every problem is going to be really simple so that you could just do it in your head without giving it too much thought. They do get more involved and more complicated. When you're looking to factor something out, the thing we want to take out is called the greatest common factor. People often misconstrue the word greatest, and they think that they need to find a big number like 30 or 60 that can be made using those numbers. But that's sort of like a false cognate in a foreign language. Greatest common factor is actually much smaller, and the least common denominator is when sometimes the number gets bigger. A little confusing, and I can understand why people get mixed up. The greatest common factor is going to be the biggest thing these things have in common, but in order to know what it is they have in common, we need to know what exactly makes these terms. In order to figure out what makes these terms, I want to look at what we call the prime factorization of each expression. What is it that makes 6x to the fourth? Well, 2 times 3 equals 6. I know I've gone far enough because 2 and 3 are both what we call prime numbers. Prime numbers have two distinct factors, 1 and themselves. Is 1 a prime number? Based on the definition, 1 is not a prime number. It is neither prime nor composite. The definition, to remind you, says that it has two distinct or different factors, 1 and itself. 1's only factor is itself, so it does not qualify as being a prime number. Also, 2 is the only even prime number. So we broke down the 6. This is what makes 6. I also have x to the fourth. If I really wanted to expand this horizontally and get a good look at it, I could write it like that. It's not really necessary, but I'm going to do it anyway. Minus, what makes up 10? What's the prime factorization there? 10 is really 2 times 5. Again, I've made it down to two prime numbers. They just so happen to not factor any further, so that's where I'll be stopping for now. And then x to the third is really x times x. Now when I'm trying to figure out the greatest common factor, I'm really going to look at this group right over here and this group right over here and decide what is it that they can both spare, that they both have the same amount of. What is it that these have in common? Well, they definitely both have a 2. This expression has a 3, this one has a 5. This does not have a 5, and this does not have a 3. So that's something that they don't have in common. Here, we see 4 x's being multiplied. Here, we only have 3. That means the greatest amount they have in common is 3. Since 2x to the third is what they have in common, I'm going to make a note of it that this is my GCF. Since that's my greatest common factor, and I want to undistribute it, I need to divide to take it out. However, we're not supposed to just divide randomly when we do math. You're changing the value of the expression. The only way to balance out a random division is with random multiplication. So while I divide by 2x to the third, I'm really also going to multiply by 2x to the third. So I'll have 1 being multiplied out front and 1 being divided on the inside. When you have more than one term in your numerator and just one term in your denominator, and you want to reduce, you need to use what I call the pretzel method. The pretzel is an oval that we really draw, and it shows us that whatever I reduce from my denominator must reduce not only with my first term, but also with my second term. If you have 3 terms, it doesn't look much like a pretzel anymore, but maybe a little bit more like a peacock or a hand turkey. Now I'm going to reduce with my pretzel. If I cross a 2 out with that 2, I have to be able to cross out a 2 there as well. If I cross out 3 x's from top and bottom, They have to cross out there as well. This simplifies down to a 1, so it's reduced and gone. So what are we really left with now? That 2x to the third power is still out front. What's left inside? 3x minus 5. So what happened here is we undistributed the greatest common factor. Sometimes it's a little bit harder to identify what the greatest common factor is, and it takes a little bit of thinking and trial and error. But as juvenile as this may seem, it actually comes in really handy. And if you do this often enough, you will start to see the prime factorization breakdown of numbers by just looking at them, because you'll be doing this in your head. So I wouldn't really knock this method too much. I will model everything showing it that way. I know not everybody needs to see it that way, but it really can't hurt, and it will only make you stronger and better at topics that you're going to see in future lessons. Let's try example 1. Factor 32x to the second minus 56x. We need to figure out what is the greatest common factor. That means we need to break down these numbers. I'm going to break it down something like this, so I could figure out the greatest common factor by looking at everything that made up these numbers all in a row. 32 is even, so I'll start with 2 times something. 32 is definitely 2 times 16. Another reason you need to know your times tables really well. 16 is really 2 times 8, and 8, without even thinking, you should be able to say is 2 times 2 times 2. 2 to the third is 8. Really, you should know that 2 to the fifth is 32. X to the second means I have 2 more x's right there. Minus 56 is even, so it's 2 times something. 2 times what? Well, 2 times 25 is 50, but I have 6 more. 2 times 3 is 6. So 25 is half of 50, and 3 is half of 6. 25 and 3 is 28. That means 2 times 28 is 56. But 28 is still even, so let's keep going. 28 would be 2 times what? This one you should know, it's 2 times 14. But 14 is really 2 times what? 14 is really 2 times 7. But 7 is a prime number, so that's where we're done with that. This also has an x, so there's the x. Now, the minus sign or a plus sign would separate my terms, and I need to figure out what do my two terms in this example have in common. Here this has 3 2's, 2 times 2 times 2, and this definitely has at least 3 2's, so that is part of my greatest common factor. There are 2 more 2's, no more 2's, 2 x's, 1 x, so that means that we can include an x in our greatest common factor. Here we have a 7, but we don't have one there. So what is our greatest common factor? In this example, our greatest common factor is 2 times 2 times 2, or 8x. I'm going to underline all of this. However, this underline not only establishes the thing I'm looking at, but it also acts as a fraction or division bar. What I want to do is I want to divide by 8x, but I'm also going to have to multiply by 8x at the same time. I'm a little squashed for space, so I'll put my divide by 8x right here and times 8x up there. Technically, if I cross them out, I'm back where I started. Nothing changed, and that's fine. Don't forget that 8x is really 2 times 2 times 2 times x. So what does that mean? That's showing us what needs to be reduced pretzel style. This time I'll draw the pretzel with a highlighter. So the 3 2's has to cross out with those 3 and those 3. The x has to reduce with that x and that x. So what do we have left? We have an 8x on the outside that I squeezed up there. I'll rewrite it over here now. Parenthesis. 2 times 2, which is 4, x minus 7. That's our answer. How can you go ahead and check if your answer is correct? All you need to do to check if your answer is correct for a factoring question is to redistribute what you just factored out. If you get back the original problem, then your answer is correct. That means that anytime you have an answer right on a test or quiz, when it comes to factoring, you should be very confident because you could have checked and verified that you were correct. That also means that anytime you get the wrong answer for a factoring question on a test or quiz, that you can write a little note to your teacher that you realize you made a mistake because you checked your work. Being able to realize that you made a mistake is very valuable, so definitely don't underestimate its importance. Let's try example 2 together. Some of you, again, are going to immediately know what the greatest common factor is. However, I do want us to do a bit of practicing. So let's break down these numbers. What is the prime factorization of 9? The prime factorization of 9 is 3 times 3. X squared, I have another x and an x. Now, most people would write this as 3 squared x squared. Again, I'm just really breaking it all down so we get a big visual of the whole problem. 36. Now we could do the approach where we use the 2's. However, this time 36 is really 6 times 6. So you could start in your head with 6 times 6. Each 6 is a 2 and a 3. 2 times 3, 2 times 3. So what I'll write is 2 times 2 and 3 times 3. So if we group them this way, you have 6 times 6, but if we group them this way, we have 4 times 9, both of which equal 36 times x. Now we need to identify the greatest common factor. Here I have 2 3's. Here I also have 2 3's. That means 9 will be a part of my greatest common factor. Here I have 2 x's. Here I only have 1. That means only 1 x will be a part of my greatest common factor. That means the GCF for this problem will be 9x. If I want to factor out a 9x, I will have to divide the 9x out from the inside and multiply a 9x on the outside. That keeps it balanced because really we're multiplying by 1, which is also known as the multiplicative identity. Let's carry on. 3 times x is that 9x out front. Now let's look at the pretzel. I reduce a 9 from all 3 parts of the problem, both terms in the numerator and the term in the denominator, and I reduce the x from all 3 parts as well. What's left inside? X minus 4. When all is said and done, you shouldn't have anything in the denominator, and if you did something wrong. So there we have our answer. Again, you can check by just distributing and seeing if you get back the original problem. Now let's try example 3 together. What makes up 3x to the third and what makes up 375x squared? 3x to the third is just 3 times x times x times x minus 375. This one might be a little bit harder to break down, but I think we can get it. Maybe you think of quarters, 25 cents. How many quarters will it take to make $3.75? $1 is 4 quarters, so $3 is 12 quarters, and 75 cents is 3 more quarters. 12 plus 3 is 15. That means 25 cents, 15 quarters is $3.75. It's much easier to split these up. I don't really have to think as hard now. 25 is 5 times 5. 15 is 5 times 3. And x squared is x times x. What is the greatest common factor? They both have a 3 as the largest part of the coefficient that they can both contribute, and they both can contribute an x times x. This means that the GCF is 3x to the second. So even though this has a very big number, 375, the greatest common factor is still only 3. It's the biggest thing they both have in common. Now remember, if you're going to factor it out front or undistribute, you need to divide it out. But you can't just divide something randomly by an expression. You also have to multiply to keep things balanced. So down here, you have 3x squared, but we'll also multiply out front by 3x squared. Then we'll reduce pretzel style. I'm going to reduce 3 from all 3 parts, and then I'll reduce x times x, or x squared, from all 3 parts. So 3x squared is still out front. That is that 3x squared right there. What's left inside? Gone and gone. We're left with an x minus 5 to the 3rd power is also on the list of math facts that I suggested you memorize. This right here is our answer. I hope you found this section of the 5-part factoring series helpful. If you feel like you've mastered this type of factoring, be sure to give the video a thumbs up for your records. However, if you have not mastered this type of factoring yet, give this video a thumbs down so you remember that this is a video that probably deserves more of your attention. I won't be offended, I promise. It's to help you remember what you need to practice and maybe to take out a little bit of steam on the lesson video that maybe frustrated you a little bit, but eventually you'll be able to come back and give it a thumbs up and show the video who's boss. Have a great day.